Hello, welcome to our channel for R programming. In this video, we will talk about simple linear regression using R. So we know linear regression is just a module with a linear parameter to illustrate the relationship between dependent variable y and independent variable x. So when there is only one x in the model, so we call this is a simple linear regression. And if more than one x variable in the model, so we can call this a multiple linear regression. So in a simple linear regression, the fitted line can show the relationship between y and x. So this is the intercept parameter, and the slope is the beta 1. So in R, usually we can use a function called LM. So this means linear regression module, linear module. So LM with a formula, then with the data. So here the formula will typically written as y and with a tilde symbol. So in R framework, we use tilde for the relationship in the linear module. So on the left side of this symbol is dependent variable. The right side, independent variable using plus sign. So this means these variables are used as independent variables in the linear regression. And the data represents the data frames. We want to use the variable from this data. And of course, there are more complicated symbols in this formula, which we will talk about later in other videos. So here we just know this simple linear regression and no integration between the variables because we only use plus sign here. So we take a look at an example. There are 15 women aged from 30 to 39 and their height and weight. So this data coming from the R-base installation. This data frame called woman. So we can use linear module to estimate a simple linear regression between weight and height. Then can use LM, weight, tilde, height. Then data is a woman. Then the result will be assigned to an object called fit. So this object is a list type object in R. Next, we can use a summary of this object. The summary function will show most of the important information of this linear regression result. So we can also use fitted to show how the line is fitted for these variables. So next we will show how to do these operations in RStudio. So we can use fit equals LM, weight, height, then data is a woman. So this is no result, no error, it's successful. Next we can show the result of the linear regression using summary fit. So in the summary of fit, first is the linear regression form of this module. Then is the residual. So residual is the difference between opposite of the y value, opposite of the weight. Here weight is the y value. So opposite of the weight minus the fitted weight. Fitted weight is the parameter times beta times height plus beta 0, right? So this is a difference we call the residual. So this is minimum and median and first quantile, third quantile, and maximum. So next part of the result is coefficient. So here is intercept beta 0 and height here is beta 1. So these two are the estimated value, and this parameter also has a standard error and has a t-value and also has a p-value for this t-value. So this is a very low value, almost 0. And here has some notation for this 3 star, which means 0. So this means that the parameter is significant, quite significant. So the relationship is quite significant between height and weight. And the residual standard error, this is a standard error of this error, right? For the 13 degrees of freedom, because in the module is a random module, is the relationship is only the mean value of a given x value for the y. So that there are standard error for this error term. And multiple r squared 0.9091. So this is r squared, which is used to show how much the variance of the y variable is explained by its independent variable. So here 0.9091 is almost 1. It's very, very high, usually in linear regression. And this value is also the square of the correlation coefficient between y and x in a simple linear regression model. So because only one independent, only one explanatory variable in the module, so y and x coefficient, then take a square, correlation coefficient square equals this r squared. But in a multiple regression, it's not equal. So adjusted r squared is another adjusted for the parameters used in the module. So it's a little different than this one, but these two usually very close. And f statistic has a p-value is f value on 1 and 13 degrees of freedom. So this value is used to show the model is significant on the combinations of all the explanatory variable. So this value also says if it is significant, so we can say the model is meaningful. If it is not significant, so we can say the combination of these x variables has no explanatory power to explain the model, to explain the dependent variable. So because here simple linear regression has only one explanatory variable, right? So we can say this variable x has the power to explain the y. So in next videos we will show more advanced complex topics on regression model. Thanks for watching.